We are going to start with an introduction of Kaplan-Meier and life table methods. To understand how we can use survival analysis, let's look at this motivating example. In a small one-year prospective study, 10 high-risk people were followed for the development of myocardial infarction. During the study period, 3 suffered myocardial infarction, 1 died, 2 dropped out of the study, and 4 completed the study. The investigators want to understand what the probability is that a patient will survive 6 months. The figure describes when each participant joined the study and dropped out, had a myocardial infarction, died or survived, event-free until the last year of the study. As you can see, the study started at year 0, but the participants each joined at different times and had different lengths of participation time in the study. Participants 1, 6, 8, and 9 experienced no event throughout the course of the study and stayed in until the study ended in year 12. Participants 2, 3, and 5 did not complete the study due to MI or myocardial infarction. Participants 4 and 7 dropped out, and 10 died before a myocardial infarction and before the end of the study. Due to these differences in study participation, we cannot treat them as one cohort with the same follow-up time. Thus, we will use survival analysis. Survival analysis, also called time to event analysis, can answer questions such as what is the probability that a participant survives for a specific time, for example 5 years, or are there differences in survival between groups, for example between those assigned to a new treatment versus a standard treatment. The methods that are used in survival analysis include the life table method or the actuarial table method, the Kaplan-Meier method, also called the product limit method, and finally the Cox proportional hazard regression analysis that can be used to assess several risk factors simultaneously. So, what is the difference between life table and Kaplan-Meier methods? Both the life table and Kaplan-Meier methods are a form of non-parametric analysis to look at the survival times within your study. The life table method generates duration distributions for a data set and time is divided into time intervals. Whereas in the Kaplan-Meier method, the time intervals are not fixed, but depend on the occurrence of the event of interest. The Kaplan-Meier method is similar to life table, but it has a single observation in each interval. Let's look at the life table method in more detail to understand this well. The life table method presents the proportion of a group of people surviving to the end of each time interval. Loss to follow-up can occur in studies in which you follow a patient for a long period of time. Patients may drop out of the study or stop showing up for follow-up appointments. They are considered loss to follow-up. If there are no losses to follow-up, the proportion number who survived divided by the initial number of participants is used. It is extremely unlikely that no patient will be lost over follow-up time. Patients removed from the analysis without information on their survival status are termed censored. When there are losses to follow-up, the life table method assumes the censored individuals were observed for half of the time, and they represent half a person at risk. Let us have a look at an example. Here is an example of a life table. The first column indicates time elapsed in the study. The second column is the number of people that were in the study at the start of the time period. The third column is the number lost over that time period. The fourth column is the number who died. and the fifth column is the total number of people who were at risk. The number of people at risk is the total of the number who started minus the number lost divided by 2. It is divided by 2 because, as discussed, censored patients are considered half a person at risk. The last two columns are the conditional proportion of survivors, which is the survival in that time period, and the cumulative proportion of those surviving, the survival for the whole study up to that point. So how to get these two numbers? For the conditional proportion surviving, you divide the number who died, that is 226, by number exposed to risk, that is 1942.5, and then subtract the answer from 1. For cumulative proportion surviving, you multiply the conditional proportion surviving with cumulative proportion surviving from the row above, that is 0.81141 multiplied with 1. These are the calculations that have just been explained in the previous slide. So when time is equal to 1, the total number of people who died was 226. So how do we calculate the number exposed to risk? It is calculated by subtracting the number of people who started the study, that is 1962, minus half into number lost to follow up, that is half of 39, and that gives us 1942.5 as the number exposed to risk. Then for the last two columns, the conditional proportion surviving is calculated by subtracting number of people who died divided by those exposed to risk from 1. Finally, the cumulative proportion surviving is calculated by multiplying the conditional proportion surviving and cumulative proportion surviving from the row above.